This is 3.2.2, Introduction to Optimization Part 1, and we're going to take a look at linear programming. And so we're going to optimize a situation given parameters. Now, what is this word linear programming that I said? Well, linear programming is an application of system of equations. And so you're going to see the method or the methodology typically goes like this. First, there's a situation that needs to be maximized or minimized. Typically, you see this very common in like profit. How do I maximize my profit? But in a real life scenario, too, there are restrictions to the situation. You can't necessarily say, well, to maximize my profit, I'm going to sell 1 trillion hamburgers. Well, what's the likelihood of you actually selling 1 trillion hamburgers in a month? It's not likely. And on top of that, where are you going to get all the food? Where are you going to get the beef? Where are you going to get the supplies for that? And so there are always going to be restrictions to the situation. And so that's where our inequalities come in. Now, because we're going to end up with a system of inequalities, for step 3, there is going to be an overlapping region. The solution is going to exist on that overlapping region. Now, more specifically, the vertices, or where the lines or the borders intersect, those are going to be the situations that can be maximized or minimized. Okay, so we're looking for those vertices. And then the last is we need to verify those set of vertices within the situation to see which one is going to give us the maximum or the minimum. So let's take a look at our first example. It says a store sells 2 types of toys A and B. The store owner pays $8 and $14 for each 1 unit of toy A and B respectively. 1 unit of toy A yields a profit of $2, while a unit of toy B yields a profit of $3. The store owner estimates that no more than 2,000 toys will be sold every month, and he does not plan to invest more than $20,000 in inventory of these toys. How many units of each type of toy should be stocked in order to maximize his monthly total profit? All right, let's take this apart. So that first thing we said for linear programming was to find the situation that needs to be minimized or maximized. And so typically, that's what it's asking us to do. Now, if you notice at this part right here, the very last part of this paragraph says how many units of each type of toys should be stocked in order to maximize his total monthly profit. Okay, and so that right there, that's going to be my first step. But then there's also information that talks about that profit. And so it says 1 unit of toy A yields $2 profit, and then 1 unit of toy B is $3 profit. And so piecing that together, I can say my profit is $2 per toy A I sell, plus $3 per toy B that I sell. And so those would be multiplied together. Like if I sell 2 toy A's, well, $2 times 2, well, that gives me $4. And it's kind of easier for us to relate it to X and Y. And so if I say, A is X and B is Y, then I can say my profit is 2X plus 3Y. This is the situation that I need to complete. So to do that, I need to now look for the restrictions to my situation. So for example, I can't just go out and sell 1 million toys A or 1 million toy B's. And so we have to look at where the information and that it talks about, oh, I only have so much money to spend, or I can only make so much a month. Those are the types of situations that we got to look at. So the first restriction is cost. And so if you look at here, it says that he can't have more than $20,000 in inventory of these toys. So I need to look through there and say, okay, what talked about cost? And so it says he does not plan more than $20,000. That was one. And then it also says, oh, he pays $8 and $14 for each 1 unit of toy A and B. So there it is. So now $8 to toy A, $14 to toy B. That has to be less than or equal to the $20 because he doesn't want to spend more than that. So the maximum dollar amount needs to be that $20,000. So there's my first restriction. The second restriction is going to be the number of toys. Because right here, it says that he can't make more than 2,000 toys for inventory, right? Can't sell more than that. So that means the number of toys, just toy A and toy B, so X and Y, those number of toys has to be less than or equal to 20. And then the last restriction, and this one's kind of obvious, but kind of not. It's like you're going to see how why it's obvious, but can't make a negative number of toys. And so because of that, I could say that the number of A toys and the number of B toys have to be greater than or equal to 0. I can make 0 toys, but I can't have more than 0 or less than 0. And so now the third step is we're going to take them and we're going to see where they need to overlap. And so what I did is on Desmos, I entered in those restrictions that I just created, and this is the region that it gave me. Now if you noticed, basically this region right here, all the way through, this region right here, we call that the region of feasibility. And that's where all of my solutions work. And so the vertices are what's important. 0, 0, 0, 1,428, and then this one and this one. I have them all listed right here. Those vertices are the potential for me to either maximize or minimize my scenario. And remember, we were looking at the most profit, so I'm trying to maximize it. And so then, once you do that, and it takes some time, entering in Desmos, but we already know how to enter all of that into Desmos, or a graphing calculator. Now what I need to do is I need to go through and I need to take these values, and I'm going to take my X value and my Y value, and I'm going to plug them in. So I plug them into my X, I plug them into my Y, and I have all of that mapped out here. So 2 times 0 plus 3 times 1428. And then after you go through and you find what your profit's going to be for all those scenarios, here's where it maximized my profit. And so to do that, I would need 1,333 for A and 666 for B. Now I know that in our graph here, you see how there's decimals? You want to round down. You can't produce half a toy, but if I produce, let's say, 667, that might put me outside of this region, and outside of that region's impossible. So you always got to round down on decimals. And so verified in my vertices, I found out that that's the best scenario, and that's my answer. So what did we learn today? Well, we talked about linear programming. It's a good idea that when we do linear programming to go back and review those steps. Always focus on what it is that we're trying to look at. Remember, there's a scenario that we're trying to maximize or minimize. We have to take a look at the restrictions that we're going to do, and so we can take those restrictions and we're going to put them on a graphing calculator. It makes it much quicker and much easier. And the reason why we put them on the graphing calculator is we're trying to see that region in which they all overlap, and we need to find the vertices. And then once we find the vertices, we plug each of those vertices back into our, we call it the objective function, or the scenario that we're trying to maximize or minimize, and that's going to give us our solution. This does conclude our lesson. Any other questions, please leave them in the comments.